All right. Today we're going to talk about using the recursive formula for geometric sequences. This is very similar to what we did yesterday, but instead of adding each time, we're going to be multiplying. A few reminders. You'll recall that R is the common ratio between the two terms. It's what you're multiplying each time. You can always find R by going A of n plus 1 is bigger than A of n. Put that over each other and reduce the fraction. That's always going to give you R. Also, when you're doing a recursive formula, you always need to have the first term, otherwise you can't do anything. So let's go ahead and take a look at example 1. We're given our first term, 18. We're also given our recursive formula. A sub n is equal to A of n minus 1 times 0.5. So we have our first term, A1 is 18. Now the next term would be A2 is going to be the same thing as 0.5 multiplied by A of 2 minus 1. So what I did there is I plugged in 2 for n in both places. It was already right there, and I plugged it in for n there as well. Now we can go ahead and do just some really basic arithmetic here. 2 minus 1 is 1. So this is the same thing as 0.5 A1, which would be 0.5 of our A1 value, which is 18. 0.5 of 18, just multiply those two numbers, we get 9. Now similarly, we can do the same thing for the other two values. We get 0.5 is equal to A of 3 minus 1, which becomes 0.5 of A2, which just gives us 0.5 of 9, which is 4.5. Our last one, A4 is equal to 0.5 times A4 minus 1, which is 0.5 of A3, which will give us 0.5 of 4.5, which if you reduce that math, you get 2.25. That's how that formula works. Now for your homework, I only expect you to use this formula for the questions 1 through 4. The rest of them, you can play it a little bit more fast and loose with the formula. Just take the general principle of it and give it a shot. Let's go ahead and look at example 2. We start with 256, then we go to 64, then 16, then 4, so on and so forth. We've got our first term, which is right here, it's just 256, the first number. And then from there, we're going down a certain amount. It's hard to tell exactly how much just by looking at it. So we can go ahead and use the formula that I already mentioned up here and plug it in. So we'll go A2 over A1, 1 plus 1 equals 2 over A1, which would be 256 over 64, which would be 1/4. So our R value is 1/4, giving us the formula A of n is equal to A sub n minus 1 times 1/4. Now from here, we can use this formula to figure out the sixth term like it asks us to. However, you'll notice we were already given our first term, our second term, our third term, and our fourth term. If it's all right with you, I think I'll go ahead and use our fourth term to figure out our fifth term. A of 5 for our fifth term is equal to A4 times 1/4, which is the same thing as 4 times 1/4, which is 1. So A5, or the fifth term in the sequence, would be 1. Similarly, we can go ahead and do the same thing to find the sixth term like it asks us to, which would be a6 is equal to a5 times 1 over 4, which would become 1 times 1 over 4, which would be 1/4, which would be our answer for that particular problem. All right, I'm going to go ahead and switch colors while I'm thinking about it. Let's go blue. We're going to go ahead and look at example number 3. The number of boxes below is our sequence. So in the first stack, it looks like we've got 3 boxes there. In the next one, we've got 6. In the next stack of boxes, we've got 12. And we've got 24. Just a general observation, it looks like we're doubling the amount of boxes in the pile each time. The math way to say doubling is times 2. So in this case, our R is 2. And our A1, where we started, is 3. If we had to write that as a formula, we would get A of n is equal to A of n minus 1 times 3. Now, we are already told that we've got our first 4 terms. We're supposed to find term 6 again. So we can kind of go ahead and do the same thing that we did the last time to figure out what our 6th term would be. So that'll be A5 is equal to A4 times 3. So the current term is equal to the previous term times 3. So that would be, oops, I made a mistake, didn't I? Let's correct that. Instead of times 3, since we're doubling, that should be 2. There we go. My bad. I apologize. So we have A4 times 2. That would be 48 boxes. Let's keep going. A6 is going to be A5 times 2, which will be 96 boxes. Good. All right. There's our answer. We'll do the last example, and then we'll go ahead and look at one of the graphing problems just to make sure that we understand how to do that. You drop a ball from a building and record the heights of its bounces. The height of the ball in the first bounce is 20 feet. The height of the ball in the second bounce is 16 feet. The height of the ball in the third bounce is 12.8 feet. So let's just draw a quick little picture to illustrate what's currently happening. We have our ball. It comes down. It's going up. Then it goes up a little bit less, goes up a little bit less, and so on and so forth. So the first bounce is 20 feet. The next bounce is 16 feet. And the third bounce is 12.8 feet. Now we can tell right away that our first value, our A1 value, is 20. That's the first bounce. From there, to me, it's not immediately obvious what our R value or what we're multiplying by is. So let's go ahead and use our little formula again of A to the n plus 1 over A of n, which becomes A2 over A1, which in this case would be 16 over 20. We could do that math, and let's write this as a decimal as opposed to a fraction this time, and get 0.8. It doesn't matter whether you use a decimal or a fraction. I just know most students prefer decimals. So now we can go ahead and fill in the rest of our formula. We get A of n is equal to 0.8 times A of n minus 1. Now we already know that this is the first value, this is the second value, and this is the third value. Let's go ahead and see if we can figure out term 6 like it asks us to. So we get A of 4 is going to be 0.8 times A3, which would be 0.8 times 12.8. Oops. Which is 10.24. Next one down, we get A5 is going to be 0.8 times A4, which is equal to 0.8 times 10.24, which is 8.192. Sorry, I'm running off the page. A6, I'm going to just move over a little bit. A6 is going to be 0.8 times our previous one, A5, which is 0.8 times 8.192, which is 6.5536. So there's our answer. Now let's go ahead and just look at one of the graphing ones really quickly. Let's look at number 12. You have 160 coins. Unlucky, the leprechaun steals half your coins every week. So even though 160 coins is our first value, our A1, in this case, that represents our week 0. It's kind of the most confusing part of these things. Sometimes they have to be very specific on whether or not it's the week 0 or the week 1. But since the first stealing would have the amount of coins that we're going to take, the first value is going to be 160. Now, let's play a little bit fast and loose with our formula this time. I don't think we necessarily need to write it all out. I think we're to the point where we can just kind of look at it and take it by half. So let's go to A2. Half of 160 is 80. A3, half of 80 is 40. A4, half of 40 is 20, and so on. Let's go ahead and graph this. I'm going to graph our points in red. So week 0, which is our first value, is 160. Week 1 becomes 80, 50, 60, 70, 80, right there. 40, 20, 10, 5, 2.5, 1.25, 0.625. You'll notice if we were to connect those dots together, which I don't necessarily think makes a ton of sense in this case, it would make the shape of a what's it called? A exponential function. Keep that in your back pocket. That's something we need to keep in mind. The recursive formula for this would be a of n is equal to 1/2 a of n minus 1 with our a1 value of 160. How many coins would we have after the 8th week? We would have 0.625 of a coin. Which, honestly, if it was a leprechaun stealing it, they would just steal all your money. As always, let me know if you've got additional